Hello friends, Mr. Burrell here. Last lesson we talked about rational expressions. We kind of had an introduction to rational expressions and how to simplify rational expressions. We talked about how rational expressions are, when I'm talking about rational numbers, they were numbers that could be written as a fraction. Rational expressions are just expressions that can be written as a fraction. So anything that has a little fraction bar in the middle, if we can write it as a fraction, that's a rational expression. Today, we're going to extend beyond just simplifying rational expressions. We're going to talk about how to multiply and divide rational expressions. So if you have an idea in your brain of how you remember how to multiply and divide fractions, this will come very easily to you. So by the end of this lesson, this is what I want you to be able to do. I want you to be able to multiply rational expressions and divide rational expressions. Pretty intuitive that that's what I want you to do, since that's what this lesson is called. So multiply and simplify the following rational expressions and state the excluded values. So before we get into that, these are in your guided notes, keep that in mind. But remind yourself, how do you multiply fractions? What do we do when we multiply fractions? Well, for example, if I have the fraction 2/5 times by 3/4, when I'm multiplying fractions together, I multiply the numerator, or the top, straight across, and I multiply the denominator, or the bottom, straight across. So 2/5 times 3/4 is the same as 2 times 3 over 5 times 4. I multiply the tops and the bottoms. And 2 times 3 is 6, 5 times 4 is 20. So when I multiply those fractions together, I get 6/20ths, and then I kind of reflect back to our last lesson, and I'm going to reduce or simplify that fraction or that rational expression, because in the top and the bottom, I can divide the top and the bottom of this fraction by 2. 6 divided by 2 is 3. 20 divided by 2 is 10. Another way you can think of multiplying these expressions and simplifying them, if I have 2/5 times 3/4, and I get to this step, 2 times 3 over 5 times 4, I can then write out all the factors that make up the numerator and the denominator. So you'll notice in the bottom, I split this number 4 into 2 times 2. So I have 2 times 3 in the top, 5 times 2 times 2 in the bottom. Right off the bat, I see, since I'm multiplying these, 2 divided by 2, that cancels right out, and I'm left with 3 over 5 times 2, which is 3/10. Same thing I got over here. So a couple different ways you can look at these multiplication problems. So we're going to extend this. Instead of just dealing with numbers, we're going to be dealing with polynomials, with expressions, with variables in them. Okay, example number 1. I have 2x over 3 times 6 over x. So when I multiply these together, I'm going to multiply the numerator and the denominator. So 2x times 6 is 12x. 3 times x is 3x. So either from right here, I can automatically know, okay, I need to simplify this. I need to cancel out anything that I can. If you notice, 12 can be written as 4 times 3. 4 is 2 times 2. So I could rewrite this numerator as 2 times 2 times 3 times x. And the denominator I could write as 3 times x. All these terms multiplied together on the top and all these terms multiplied together on the bottom. Anything that's also in the top and also in the bottom, I can cancel out and simplify. So I get 2 times 2, which is 4 in the top, and just 1 in the bottom, which simplifies to 4. So my solution here is 4. So the other part of the instructions here, if I were to go back to this page, was to state the excluded values. So notice here, in my original expression, I need to look in the denominators, I need to look in the bottom and see what values of x are going to cause me to divide by 0. So in the bottom here, I have an x. So when x is equal to 0, that's not going to work. In this expression, I can't divide by 0, so my excluded value is going to be x equals 0. Remember that an excluded value is a value of x that will make me divide by 0, or make a denominator or the bottom of one of those fractions 0. Okay, let's do another one. This one I have full-on expressions here. So I have x plus 6 over x minus 3 times x minus 3 divided by x minus 2. So notice when I multiply these, I'm going to treat everything in the top and bottom of these fractions as its own entity, as its own factor, as we have called them in the past, right? So in the top, when I multiply straight across, I'm going to get x plus 6 in parentheses times by x minus 3 in parentheses. In the bottom, I'm going to get x minus 3 in parentheses times x minus 2 in parentheses. So I have two factors on the top, two factors on the bottom here. So remember, right back in this step, if I had factors that were the same on the top and on the bottom, I could cancel them out. And all those factors in this case are separated with these parentheses. So notice here, I have x minus 3 in the bottom, x minus 3 in the top. Those are going to be able to cancel out. X minus 3 divided by x minus 3, that's going to cancel out to 1. So I'm left with x plus 6 over x minus 2. You can write these in parentheses if you want. Since they're the only factors left, I can just leave them without parentheses also. So my solution, my answer here, when I simplify these, when I multiply these together, is x plus 6 divided by x minus 2. So if that's my solution, the last thing I need to check for is excluded values. So in the denominator here, I had x minus 3 and x minus 2. Those are my factors. Remember, any point where any value of x that would make the denominator equal to 0 is an excluded value. Well, in the denominator, I have x minus 3 times x minus 2. Well, what's going to make those equal 0? Well, let's look. I'm going to set each of those terms equal to 0. Each of those terms that are in the bottom, I'm going to set them equal to 0 and solve for x. This hopefully should ring a bell. I'm going to add 3 on both sides here to get x equals 3 as an excluded value. I'm going to add 2 on both sides here to get x equals 2 as an excluded value. So here's my answer right here, my simplified expression, x plus 6 over x minus 2, and these are my excluded values, or the values that would make me divide by 0. Okay, let's look at example 4. I'm going to let you do example 3 on your own if you would like to do that. So let's look at example 4. Notice here, on these previous problems, I had these questions. I had my numerators and my denominators, the tops and bottom of my fractions, already factored. So it was really convenient to know what was going to be able to cancel. These expressions are quadratic expressions, these two right here, that are not factored yet. So you guessed it, we're going to have to factor them first and then to determine what can cancel out in the top and bottom. So let me show you. So x squared plus 4x. I'm going to factor this. It's already in standard form. No greatest common factor. I'm going to multiply 1 and 4 together. What are two numbers that multiply to make 4 and add up to 4? Well, that's going to be 2 and 2. So the top of this fraction is going to be x plus 2 times x plus 2. In the bottom of this fraction, if I multiply 1 times 12, I need to find two numbers that multiply to make 12 and add up to 7. Well, that's going to be 4 and 3. 4 times 3 is 12. 4 plus 3 is 7. So in the bottom here, I have x plus 4 and x plus 3. Yeah? Feel good about that? And that's being times by the second fraction. In this first section, is there a greatest common factor between 5x and 15? Well, indeed, I can take out a 5. When I take a 5 out of both of these terms, I'm left with x plus 3 divided by 2. So in order, before I start canceling stuff out and before I start multiplying stuff together, I want to make sure that all of my expressions are in factors, are in factored form. All these little parentheses, because those are way easier to be able to simplify. So when I multiply these together, I get x plus 2 times x plus 2 times 5 times x plus 3 all over x plus 4 times x plus 3 times 2. See that? So is there anything in the top and in the bottom that can both cancel? Well, I have x plus 3 in the bottom, x plus 3 in the top. See that? So since I have that in the top and the bottom, they're going to cancel each other out. I can simplify those, and I'll be left with x plus 2 times x plus 2 all over x plus 4 Oh, and there's a 5 up here. I'll write this 5 over here. On the bottom, I'm left with just a 2 and an x plus 4. So I have 5 times x plus 2 times x plus 2 all over 2 times x plus 4. Whew. Can these 5 and 2 simplify anymore? 5 divided by 2, my regular numbers here? No, that's as simplified as I can go. So, since that is as simplified as I can go, this is my final answer. 5 times x plus 2 times x plus 2, all divided by 2 times x plus 4. That's my simplified answer. Sometimes you'll see now that it's simplified that I can multiply these all together and I have a expression on the top and an expression on the bottom. But for now, I'm going to have you keep it in this simplified, factored out form. So if that's my multiplied expression, now I need to check for excluded values. So let me go back here before I canceled anything out. I need to see what values of x will make the denominator equal to 0. So I need to set x plus 4 equal to 0 and x plus 3 equal to 0, because those are my factors in the bottom that have x's in them. So I'm going to subtract 4 on both sides, subtract 3 on both sides, and I'll get x equals negative 4 and x equals negative 3 as my excluded values, or the values that would make me divide by 0. Okay, that's multiplying rational expressions. Now let's talk a little bit about some definitions before I talk about dividing rational expressions. Dividing rational expressions is going to be very similar to multiplying. The process is going to be basically the same. So you maybe have heard this expression before, copy.flip, also known as keep, change, flip. So when I am dividing fractions, the first fraction is copied, the division symbol is changed to a multiplication, so I change to the dot often. We look at this little dot as the multiplication symbol. And then the second fraction is the reciprocal, or I flip it. So that's what copy.flip means. So the instructions for these next expressions are going to be divide and simplify the following expressions and state the excluded values. So I have this problem, 3/4 divided by 2/3. When I have a division problem, I'm going to copy, dot, flip. So when I'm dividing fractions, I copy the first fraction, I put a dot to multiply, and I flip the second fraction. So this 3/4 divided by 2/3 turns into 3/4 times 3/2. When I divide fractions, I flip the second number. So 3/4 times 3/2, I multiply across the top, multiply across the bottom. Now I'm doing the exact same thing I was before. 3 times 3 is 9. 4 times 2 is 8. My final answer is 9/8. Okay, so you can imagine the process is going to be very similar with our expressions. So here I have the problem 4/5 divided by x over 2. So when I rewrite that, if I do copy.flip, I'm going to copy 4/5 dot and then flip this second fraction so it reads 2 over x. And then I'm just going to multiply straight across. So that equals 8 on the top, 5x on the bottom, and nothing there can simplify, so I'm as simplified as I can go. That's my final answer, 8 over 5x. When I'm looking at my excluded values, again, before I simplified anything in this step, I need to look in the bottoms. I need to look in the bottom of these fractions and see what value of x would make the denominator equal to 0. So in this case, I have just x in the denominator. So when x is equal to 0, that's an excluded value because that will force me to divide by 0. Okay. Example 6 here. This is a division problem. I have 3x plus 6 divided by x minus 1 divided by x plus 2 over x minus 5. So I'm going to copy 3x plus 6 over x minus 1 dot and then flip. So x minus 5 on the top, x plus 2 on the bottom. Sorry, I put this parentheses here. So before I actually multiply them together, I need to see if I can factor any of these expressions, if any of them can be factored. This one cannot, this one cannot, this one cannot, but this one, notice I can take out a greatest common factor of 3 and 6. Namely, if I write my little arrow here, I can take a 3 out of both of those terms and be left with x plus 2. 3 times x plus 2 over x minus 1 times by x minus 5 over x plus 2. Okay, I have all those in factored form. Now I'm going to multiply them together. Multiply straight across the top, straight across the bottom, writing all of those factors in parentheses. So on the top, I have 3 times x plus 2 and x times x minus 5. I wrote that x minus 5 in parentheses. In the bottom, I have x minus 1 times x plus 2, just like so. So now in order to simplify, is there anything the same in the top and in the bottom? Any similar factors? Well, I have x plus 2 in the top, I have x plus 2 in the bottom, so I can cancel those out. Which leaves me with 3 times x minus 5 divided by x minus 1. And since x minus 1 in the bottom is the only factor that's left, I don't need to write it in parentheses, but you can. So that would be my final answer. A lot of times they'll leave it simplified like this. Maybe if you want to, you could multiply these back together if you don't want to see the parentheses there, which would make your answer 3x minus 15 over x minus 1. I believe the quiz answers will be this way with the factored form. You'll see solutions in both of those manners. So this is my final answer. 3 times x minus 5 over x minus 1. Now I need to check for the excluded values. So if I go back before I simplified anything, what values of x would make the denominator equal to 0? Well, I need to set x minus 1 equal to 0 and x plus 2 equal to 0. So if I add 1 on both sides, subtract 2 on both sides, I'm going to get x equals 1 and x equals negative 2. So my solutions, my excluded values in this case that would make the denominator equal to 0 are x equals 1 and x equals negative 2. Okay, let's do one of these problems. So don't be scared by this big fraction sign. When I have x squared plus 2x minus 15 over x squared minus 4x minus 45, and this big fraction sign, that's another way of saying divided by x squared plus x minus 12 divided by x squared minus 5x minus 36. This is just another way of writing division problems with these big fraction bars. We don't love seeing fractions on top of fractions, so I'm going to write it like this. X squared plus 2x minus 15 over x squared minus 4x minus 45 divided by x squared plus x minus 12 over x squared minus 5x minus 36. So first step when I'm doing these division problems, I need to change it to a multiplication problem. So I'm going to copy this first expression right here, dot flip, and then I'm going to flip the second expression like so. Okay, next step, I need to put all the numerators and the denominators, every section of this rational problem here, into factored form. So like here, I need two numbers that multiply to make negative 15 and add up to 2. Well, those two numbers are going to be 5 and negative 3. Here, I'm going to need two numbers that multiply to make negative 45 and add up to negative 4. Well, those numbers are going to be negative 9 and 5. Okay. Here I need two numbers that multiply to make negative 36 and add up to negative 5. Well, that's going to be negative 9 and 4. Negative 9 and 4. And lastly, I need two numbers that multiply to make negative 12 and add up to 1, which is going to be 4 and negative 3. I kind of whizzed through those factors. If you need some review as to how we factor those expressions, please come and find me. So I can write the numerator and the denominator of these expressions in factored form. So let me just write each of these fractions. I'm going to fill in each of these parentheses with the factors, the factored form of each of these quadratic expressions. So up here, I have x plus 5 and x minus 3. 5 and negative 3 were my golden numbers. Here I have x minus 9 and x plus 5, my golden numbers. Here I have x minus 9 and x plus 4, my golden numbers. And then here I have x plus 4 and x minus 3. Whew! So I've done my copy dot flip. I've switched this to a multiplication problem. I've factored all the quadratic expressions that I can. Now I need to multiply straight across. So if I'm multiplying here, I can really write x plus 5 times x minus 3 times x minus 9 times x plus 4 all over x minus 9 times x plus 5 times x plus 4 times x minus 3. So, are there any factors on the top and on the bottom that I can cancel out? Well, I have x plus 5 and x plus 5 on the bottom. That'll cancel out. I have an x minus 3 and an x minus 3 on the top and bottom. Those will cancel out. I have an x minus 9 on the top and an x minus 9 on the bottom. And I have an x plus 4 on the top and an x plus 4 on the bottom. Huh! Everything cancels out. So what does that equal to? Anything divided by itself cancels out to be 1. So this big multiplication problem simplifies out to be equal to 1. Crazy. That's really cool. But there's still one more thing I need to do. I need to check for my excluded values. So any number of x that would make the denominator equal to 0 before I simplify. So in this pre-simplified form here, I have x minus 9 equals, and I'll set that equal to 0. I'll set x plus 5 equal to 0, x plus 4 equal to 0, x minus 3 equal to 0. If I solve for x in each of those little mini equations here, I'm going to get x equals 9, negative 5, negative 4, and 3. Those are my excluded values, or the values that would force me to divide by 0. So as we're simplifying these and as we're finding excluded values, that's going to come in handy in the upcoming lessons when we start talking about solving equations involving these rational functions. We'll talk about how some solutions we get won't actually work because those solutions are excluded values, or values that would make me divide by 0, which I can't do. So that's the end of this lesson. I want you to rank yourself, hopefully on a scale of 0 to 5. I hope you're able to multiply rational expressions and divide rational expressions. Those are very closely related subjects. Hopefully you can do both of these. I hope you enjoyed this. I hope that this video was helpful. If you have any questions, please reach out to me and let me know. And I hope that you enjoyed this as much as I did.